All right, so we've been talking a lot about evaluation. Now we need to talk about statistical significance testing of our results. Let's go back and actually remember what our goal is here. What are we doing? Let's recenter ourselves on this. We have two information retrieval systems, two search engines. We'll call them A and B. Let system A be our old existing algorithm. And then we had some good ideas to deal with some problems. And so we invented a new system B or made some changes to an algorithm here or there. And we want to know, is B better than A? And this is our first step to deciding whether or not we are actually going to roll it out and release it, for example, to customers. If we can get past this stage of working with an offline evaluation to determine whether B is better than A. If it passes that, then we can do things where, maybe we do side-by-side testing with some assessors actually looking at the results. Then we can do a bucket test, deploying it to the real website and actually seeing for a small portion of traffic what happens to our online measures of effectiveness for the users. And if all that checks out, then we could roll out that change to all of our users. So how do we go about doing our offline evaluation? Well, we have to start with our test collection. This is our documents, our queries, our topics, and our relevance judgments. Okay, so that has to be put together. And of course, it has to be applicable for our system. We don't just go use any old test collection. It should actually be reflective of our system that we're needing. And as well, we pair that with an effectiveness measure. So for example, NDCG, if that's an appropriate measure for our application, our usage. All right. Then we're going to go and we're going to run both of our systems on the topics or queries, whatever we want to call them, and we're going to measure the quality produced with those systems with our effectiveness measure. Okay, great. So now we have, let's say we had 50 topics. Now for system A and system B, we have 50 different scores. Is B better than A? Well, the simple thing might be to say, well, why don't I take a summary statistic like the average, and I'll average the scores for A and average the scores for B, and if the B's average is better than A, I will say B is better than A. Well, that's one way. Maybe you want to take the median. Maybe the median is better. Maybe you want to actually talk about the number of times, the number of topics where system B is better than A. So sort of think about the number of wins. How many times when it goes against competition against A is it better? These are all ways for us to take those 50 scores for A and 50 scores for B and come up with some sort of measure of overall is one better than the other. So there's a lot of these what we would call sort of test, I can't pronounce things today. Test statistic, okay? You might say it's your summary statistic, but we're going to call this a test statistic, okay? So this is what we're going to do. We got to run some statistic over those 50 measurements for A and 50 measurements for B, and we're going to be able to make a comparison then. All right, now let's say we took the average. Let's say the average for B is greater than the average from A. The next question is, okay, so I guess there should be a 2A in here, which is, or a 2B, but I'll just say this, measure quality, and then I'm going to send it into, we'll call it a test statistic. And I'll say, for example, the mean, because I can write mean there easier than I can write the word average. Same difference. Same thing. Anyway, so now we get the, let's say the difference, the mean difference, okay? So, all right. The first question you need to ask yourself is, do I see this as a significant improvement? Too often people ask the next question, is it a statistically significant improvement, before asking themselves the first question, is it a significant improvement? If it's not a significant improvement, if it hasn't increased in an amount that makes you go, ah, that could make a difference, or that's important, or I think this is an improvement. If you're just like, geez, it's like infinitesimally better, it's not probably going to be something that users notice. You maybe want to note it for future reference or something. Maybe there's something there in your idea of how to improve B versus A. Maybe you needed more topics. Maybe something is actually wrong with your experiment. I don't know. But if it's not a significant difference, no one's going to care if it's statistically significant. It needs to actually be an improvement that we care about. Now, let's say, oh, if I was to show those numbers to my boss would be excited about those differences. Well, all right, now, is it a statistically significant improvement? And this is a question that we really want to know with regards to, well, we set up this experiment. There's only so many topics. Maybe it was just sort of luck based upon those topics. Consider, for example, let's say you had a single topic, black bear attacks. Well, wait a minute. One topic, one query? System B is better than system A. And we've looked at one. What if there's another one and we're like doing web search, and it's a navigational query, University of Waterloo. Yeah, I mean, would you base your decision upon one result? No, you're going to need to see across many different searches that system B is working better than A. So it's sort of obvious that in the extreme, oh, I only tested it on one thing, you might very well be able to come back and say, maybe it's only better on that one. How many of the queries, across how many of them is it better? Maybe as we build up more and more of these topics, we'll have more evidence and more faith in our understanding about whether B is actually better than A. So while it's obvious at only one query that it could just be a fluke, it could just be that it's better on that topic, the same holds true even as we increase this. We need to know, could it just be that we don't have enough sample points? We haven't tried enough queries? Could it just be luck based upon the picking of these queries that system B looks better than system A? This is what our statistical significance testing gets at, is could it have just been the sort of the natural randomness in this setup that we had in the system? Did we not get enough measurements to really say with certainty? Or did we actually get enough measurements that we feel quite confident that the difference that we see is actually not just due to chance, but is actually due to a true improvement in performance for system B? That's what we're getting at. That's the question we want to resolve with our statistical significance test. Was it random luck that B was better? Or was it truly, how much faith do we have that it is actually better? And that's what we're going to get at in this. To do these videos for the statistical significance testing, I'm probably going to break it up into a series. I know I'm going to at the moment go and pause this or stop it. And so we're going to have a series of videos we'll try to get these all worked out together. I hope. I'll have to go back and forth between the computer and the whiteboard. All right.